if I'm just trying to find antiderivatives for a function, we've said I have to include a constant of integration. If my function is 2x, my antiderivative isn't only x squared, it's x squared plus any constant. If, in addition to having a function, I also specify one particular function value, we can narrow down that whole big family of antiderivatives with any value of c, the constant of integration, to just one specific one with one particular value of c. Let's take a look at how that works. I'm looking for an antiderivative for this function, 7 root x plus 4, specifically the one for which the function value at 0 is 2. Well, antiderivative, I definitely am going to need to antidifferentiate or integrate. So I have 7 times the square root of x. That's not an x. That's a 3. But as long as I'm undoing things, we might as well make it into something more useful. We'll call it x to the 1/2, square root of x, plus 4 with respect to x. Well, we can find antiderivative for the first part and the second part separately and add them together. And the constant is just a constant. It's just out there. So I got 7 times x to the 1/2 plus 1, which is x to the 3/2, over 1/2 plus 1. Yes, we are going to fix that in a minute. Plus 4, you think of this as 4 times x to the 0. So its antiderivative is 4 times x to 1 higher power over 1, plus the constant of integration. And let's see, I'm going to rewrite this. 1 over 3/2 is 2/3. 7 times 2/3 is 14/3. Plus 4x plus the constant of integration. So there's all the antiderivatives for my function. This time, I don't want all the antiderivatives. I want specifically the one where when I evaluate it at 0, I get 2. So this is all the antiderivatives. But I want f of 0 to be 2. Well, f of 0, I'm going to substitute 0 here, so that's 14/3 times 0 to the 3/2 plus 4 times 0 plus c. Well, I like zeros. Those are good. Those are easy to work with. Which means the value of c, my constant, in order for all this to come out to 2, the constant must be 2 because everything else is 0. So the particular antiderivative is my function is the general antiderivative, so that's 14 x to the 3/2 over 3 plus 4x. And the particular one that has f of 0 equals 2 is the one where the constant is specifically 2. So this is not just any old antiderivative or all the antiderivatives, it's the specific one where the value of the constant is exactly 2. We can use this idea for something like this. We've talked about position, velocity, acceleration in the past. We know that velocity is the derivative of position. Acceleration is the derivative of velocity. We can do that the other way around now. If I know the acceleration, I can find the velocity by finding an antiderivative. Here we go. An antiderivative of 2t plus 3. Well, Antiderivative for 2t is t squared. Antiderivative for 3 is 3t. Constant of integration. But not just every antiderivative. In particular, I know that the velocity at 1, I want to be -3. Well, this is the velocity at any time. We're going to narrow this generic antiderivative down to the particular one where the velocity at 1 is -3. I'm actually going to add something in here. I'm going to call this C1 because since I'm looking also for acceleration, or looking also for position, I'm going to be integrating again, so I'm going to have another constant. They're probably not going to be the same. So let's see. V of 1 is -3, and that's, I'm substituting 1 into my velocity function here. So that's 1 squared plus 3 times 1 plus C1. Well, 1 plus 3 is 4. If I want to solve for C1, I'm going to subtract 4 both sides and get C1 is -7, which means now I know my velocity function is the particular antiderivative, t squared plus 3t minus 7. That's what's going to satisfy that initial condition. I also want the acceleration. I know, I already had the acceleration. I'm going the other direction. I also want the position. My position function is the antiderivative of the velocity. So here we go again. I'm going to integrate again. The integral of t squared is 1/3 t cubed. The integral of 3t is 1/2 t squared times 3. Like that. Integral of -7 is -7t. And I'm going to have another constant of integration, and I don't expect it to be the same as the first one, so I'm going to give it a different name, C2. We also have an initial condition for position. Try to say that 3 times fast. S of 0 is 2. Here we go. S of 0, I'm going to take 0 and substitute into my position function. Yes, we like zeros with polynomials. That's 0 cubed over 3. And 3 times 0 squared over 2. Yep, like the zeros. Minus 7 times 0 plus C2. And I know that's going to turn out to be 2. All zeros except for the constant. So C2 is 2. And my position function is the particular one, t cubed over 3 plus 3t squared over 2 minus 7t plus, in particular, C2 is 2. Let's see, did we answer the question yet? I don't think we did. Find the position and velocity at t equals 2. Well, I have the position function and the velocity function. We just need to evaluate them at 2. The velocity at t equals 2 is 2 squared plus 3 times 2 minus 7, which is 3. And the position at t equals 2 is 2 cubed over 3 plus 3 times 2 squared over 2 minus 7 times 2 plus 2, which is, oh, this is fun, 6 minus 14 is negative 8, plus 2 is negative 6. Negative 6 plus 8 thirds. Negative 18 thirds plus 8 thirds is negative 10 thirds. So we found, just to recap, we found the velocity function. We found the particular velocity function by finding the value of the constant, and we evaluated it at 2. We found the position of found the position function by finding the antiderivative of the velocity function. Evaluated it. That sounds like too many syllables. Evaluated it at 0 to satisfy the initial condition, find the value of the constant, and then to answer the question, evaluated at 2.